Buffer solution. Buffer solution is an acid or a base aqueous solution consisting of a mixture of a weak base and its conjugate acid, or vice versa. It resists the changing in pH. Therefore the pH changes very little when a small amount of strong acid or base is added to it. Mechanism of buffering. It is able to neutralize small amounts of added acid or base, thus maintaining the pH of the solution relatively stable. Mechanism of buffering. A buffer is able to resist pH change, because the two components, conjugate acid and conjugate base, are both present in appreciable amounts at equilibrium. They are able to neutralize small amounts of other acids and bases, in the form of H3O+ and OH, when the acid are added to the solution. Uses of buffer solutions. Buffer solutions are used frequently in pharmaceutical practice, particularly in the formulation of ophthalmic solutions. They also find application in the colorimetric determination of pH, and for research studies, in which pH must be held constant. Consider a buffer solution that consists of a weak acid and its salt, such as the acetate buffer. A very useful mathematical expression for calculations of pH is the Henderson-Hasselbalch equation. For a weak acid and its salt, pH equals pKa plus log salt / acid. For a weak base and its salt, pH equals pKa plus log base / salt. Buffer capacity, the amount of added base or acid a buffer can take before suffering a pH change of 1 unit. It is measured in millimoles of acid or base per liter of buffer. It represents the ability of a buffer solution to resist pH change. It depends upon the concentration of the buffer. Buffer capacity can be measured by Van Slyke equation. B equals B over pH, where pH is the change in pH, while B is the small increment of strong base in millimoles. Measuring of pH. There are different methods used for measuring of solutions pH. 1. Colorimetric methods. It is less accurate and less convenient, but less expensive than the electrometric method. By using pH meter. Colorimetric methods involve the use of a. Paper indicator, a strip of paper that undergo color changes depending on the pH of the solution where the strip is immersed. B. Liquid indicators. They are weak acids or weak bases that show color changes as their degree of dissociation varies with pH. The color of the indicator resembles a certain pH value. An example is universal liquid indicator. 2. Electrometric method, by using pH meter. Practical work. Materials and equipment. Materials: acetic acid, sodium acetate, and sodium hydroxide. Water. Equipment: conical flask, volumetric flasks, beaker, pipette, and pH meter. Practical work. Prepare 800 milliliters of distilled water in a suitable container. Add 5.772 g of sodium acetate to the solution. Add 1.778 g of acetic acid to the solution. Adjust solution to desired pH using 10 NaHCl. Typically pH almost equal to 5.0, then complete the volume to 1 L. Add sodium hydroxide slowly until the pH changed by 1 degree.